Hello and welcome to mCoding. I'm James Murphy. Today we're talking about debugging. There's no getting around it. No matter how smart you are, no matter how experienced you are, you're still a human and you're going to write bugs. And whether you wrote the bug or your teammate did, inevitably it's still going to be on you to fix it. And hey, if you're happy just throwing in a print statement and that helps you solve your problem, that's totally fine. This is called print debugging and it never goes away. But a lot of the time, print debugging is going to be very frustrating, and using something like a live debugger, like the one that I have open here, is going to be a lot easier. At a fundamental level, all they do is allow you to step through and pause your program at particular points, so you can inspect the state and see what's going wrong. Even basic live debugging is extremely useful and not that hard to do either. But if you've never heard about it, then you might not know it's even possible. So today we're going to take a look at sort of the main features of a live debugger and use a live debugger in order to debug this grocery list application. And don't worry, I'm going to show you how to do it in VS Code or PyCharm. Unfortunately, if you're using Vim or Emacs, you clearly enjoy the pain, so you're going to have to figure it out on your own. And as you could probably tell from watching most of my videos, I prefer PyCharm. So if you'd like to win a professional PyCharm license, go ahead and comment down below. Thanks to JetBrains for providing the licenses. But don't worry, the debugger works just the same even if you're on the free edition. Okay, so what does this grocery application do? Basically, I have a list of recipes. So here I have a spaghetti bolognese and a list of ingredients and quantities for those ingredients. Yes, I realize that a list of ingredients is not the same thing as a recipe. Sorry, I hope it doesn't make the video totally unwatchable. Each of the ingredients listed in the recipe is also listed in the ingredients list in a separate file. And in the ingredients list, it says where in the grocery store that ingredient would be found. So if I was looking for an avocado, I should look in the produce section. When I run the application, I get a list of the recipes and it asks me what I'm shopping for. So let's say I want to make 2 spaghettis, a Caesar salad, and a veggie stir fry. I just put that in and hit enter. The printout then contains the ingredients for all of the recipes that you're trying to make, so that you can go to the grocery store and just buy all the things. They're also grouped by which section in the grocery store, so that when you're out shopping, you can just get all the things by section because they're physically closer to each other. Our beta testers have reported up to a 50% reduction in time spent in the grocery store. But that was the already fixed version just for demo purposes. What we're going to be dealing with is a very similar but slightly broken version. The main difference between this one and the previous one is that this one doesn't work. Like a lot of code you're going to spend time debugging, you didn't write this code and you don't fully understand it, and quite frankly, you don't have time to read all of it in order to fully understand it. You'd like to be able to just debug the minimal amount that you need to in order to understand what you need to understand in order to fix the problem. We'll get there as soon as possible, but first, let's just see how to use the debugger at all. Unfortunately, this first step depends on which version of Python you're using. If you're using 3.11 or less, then you don't need to do anything extra. But in 3.12, they changed how debugging works, and PyCharm doesn't really support the new way that well. So go up here into help, or use the keyboard shortcut, of course. Go to registry, and find this python.debug low impact monitoring API. That is set on by default if you're in 3.12. Go ahead and turn it off. For me, it was causing spurious crashes, but hopefully in 5 years when your company starts actually using Python 3.12, this issue will be resolved. Okay, let's begin. The first thing that you'll notice about the debugger, if you try to start it by clicking on this debug icon, is that it doesn't appear to do anything different than just running the program. I still get the same choices, I can still pick my menu items, and I still get the same error. And how does this help me? In order to do something useful with a debugger, you need to set breakpoints. These are places where if Python reaches this point in the code, then it will stop and show you information. The simplest thing you can do is set a breakpoint at the very first line in your main function. Now when we click debug, Python reaches that line and then stops basically at the very beginning of our program. The main thing we can do at this point is to use these controls down here. So we have rerun, stop, resume, pause, step over, step into my code, step out, view breakpoints, and mute breakpoints. Now, normally you would memorize the keyboard shortcuts for these things pretty quickly, but for the sake of the video and you being able to see what I'm doing, I will do my best in order to actually click the buttons. Step over is basically what lets you run one line of code. So right now, we're paused at line 80, and line 80 has not run yet. When I hit step over, then it runs that line and then stops at the next line. The previous line defined a variable, and that variable now you can see down here in this list of basically all the local variables. We can go in and inspect it. We can see that there's 9 items in the list, and you can just dig down further and further and see different properties. This is a great way to get a feel for what's happened inside the local scope of a function. Step into is similar to step over in that it kind of runs one line of code, except if the line of code involves some sub-things, then it will actually go down into that sub-thing. So in this case, the next line is this load ingredient locations. So when I click step into, we actually go into that function. And normally you could continue stepping into further and further down functions, but in this case, the next thing that's going to happen is it's going to basically call this open function. But this open function is not written in Python. This is a Python built-in that's actually written in C. So if we actually try to step into that, you'll see that our live debugger like pointer to where we are kind of just disappears. Now the program is still running, it's still debugging, and if we keep going, we'll eventually get back to Python land. You can see now it came back, but it didn't show us that inside of the open function. This is just something you get used to. You typically don't have any need to be debugging very low-level functions anyway. Let's just step over that, and you can see we're now on this JSON load line, and that actually is written in Python, so we can go ahead and step into that and sort of see the implementation of this thing that's inside the JSON library, and we could go down sort of as far as we could possibly try, and eventually we'll get to a point where we can't go down any further. We can step through this line by line if we really want to, but again, this is basically low-level code that we didn't write, and we probably don't need to be debugging it unless perhaps we're just interested in how does the JSON library work. So if you've ever stepped too far down and just want to go up a few levels in the call stack, you can see the call stack right here, by the way, where I can see all the way up from the start of the module into main, into my load ingredients function, then into the JSON library, into the load function, all that you can see here, and you can see all the variables all along the way. If you're ever too far down and you want to just go back up, you can hit the step out button. That's what that's for. So let's step out of that, and now we're back into our code. Let's just step out of that one more time. So doing this, you can basically step through your entire program, and it still works as normal. You can give it input, and you can just go line by line until you eventually find the error or the crash. You can see in this case, I tried to step over, but instead it sent me up to main. What's actually happening here is this is what it looks like when you hit an exception. This is an exception being raised, and eventually it escapes outside main, and we get the error that we saw if we ran the program normally. If we wanted to start over, we just hit debug again, and it puts us back at main. But going step by step through this entire program is probably not the best way to find this bug, especially since we have a traceback, which is presumably close to the origin of the error. Let's just take a look at that error one more time. We gave it some input, and we get a type error at this particular line. So let's go there. The traceback is telling us that we're inside this function and that the error is originating here, that whatever this evaluates to is not inside of this list or this map. So what we'll do is just set a breakpoint there and click debug. We'll go ahead and just execute the program normally until we get to that point in the program. And then now we see that we stop right before that line, the one that was causing the error. In most debuggers, you can hover over stuff to see. So like this is a dictionary with key name that's ground beef and quantity 1 pound. I can see that same information here inside the local variables of this function. And if I really want to dive deep and actually evaluate expressions in real time, I can just type them in here inside the debug console. So if I want to look at this variable, then I can just print it out like that. Or if I want to look at what is the name evaluating to, then I can literally just type in whatever expression I want, and it's like I'm at an interactive session, but at this state, paused. Okay, the ingredient name is ground beef, so let's try to look that up inside of this map. And we see, well, there's the error reproduced. We get a type error. This is a list, but we're trying to use it like a map. And we can confirm that here. The ingredients, it says the type here is a list, and we can see it has 10 items. If we go ahead and look at our ingredients data, we see that indeed our ingredients data is just stored in a big list where each element is a dictionary of the name and where the ingredient is. But from the way that it's being used in the code, it seems like what we really want isn't a list of all the ingredients, but rather a map of every ingredient to where in the store it is. Alternatively, for each ingredient, we could do a linear search trying to find that ingredient somewhere in the list, but in this case, a map makes more sense. So then we need to go on a little mini mission to find where this was actually set. Where did this data come from? In this case, it's no surprise that the all ingredients locations is the one from the main, and that was just from this load ingredient locations. If we jump there, then we see that indeed we're just loading it as JSON, meaning we're getting the list form instead of the map that we're looking for. Now again, the kind of fix that you do is up to you. Do we want to change that one function? Do we want to change this where the data is loaded so that it's used a different way everywhere in the application? Or do we want to change the data itself? Totally up to you. In this case, I'm going to go ahead and say that the place that we want to change it is in this function where we load it. So we apply our little fix, convert the list into a dictionary, and then let's go ahead and check, did this solve the problem? Let's say, what do I want to eat? How about tacos? So we didn't get the same error, we got a different error. And this is an important lesson to learn. Even if you fix something, sometimes you're not done. Sometimes there's more than one thing wrong. In this case, once again, it's on that same line, but it's a different error. Here we're getting a key error, like salsa isn't a known ingredient. Let's keep our breakpoint and just debug it again. This time though, when we get here and it pauses, we're actually not right before the error occurs. Remember, it was happening with salsa, but right now we're paused with ground beef. I'm actually inside of a loop right now, and as you can see, it's sort of just going around the loop. So we're at lettuce, now we're at tomatoes, now we're at cheddar cheese, and so on and so forth. I'm sort of having to step my way through in order to get to salsa. And actually, oops, I went one too many, and now I passed the error. This is a perfect situation for conditional breakpoints. I want to stop at this line, but not every time I get to this line. I just want to stop here if the ingredient is salsa. That's a perfect use case for conditional breakpoints. So go to our breakpoint and right-click, and we get this extra menu, and it has this condition in it. Here, it will only stop at the breakpoint if the condition is true. So in this case, I'll take this ingredient name, and that needs to be equal to salsa. Then click done, and now let's debug. And this time, when I hit the breakpoint, I skipped all the previous ones, and I do indeed stop at salsa. Salsa was giving us a key error, so let's look inside our ingredients and see, is salsa actually there? So it's inside the all ingredient locations, and we do see a salsa. Salsa is right here, but it looks like the issue is that the name here is lowercase salsa, but for some reason it appears as uppercase salsa within the ingredients list. Based on the rest of them, it seems pretty clear that they were probably all supposed to just be lowercase. I mean, at the very least, the way that it's referenced inside the recipe probably just needs to match whatever's in the ingredients list. But since everything is lowercase except for that one ingredient, I think what we really want is to just lowercase the salsa. Swag. This is literally not planned. So important lesson number 2, the problem in your code isn't necessarily in your code. It could be in the data, it could be from user inputs, it could be environmental variables, it could be some kind of assumption about the operating system or file system. Be prepared to check all of your sources. The fix for this is twofold. Number 1, of course, fix the data. It should be lowercase salsa. But number 2, validate the data. So let's go back here and add in a verify that ingredients exist function. It just loops through all the recipes and looks at every ingredient in every recipe and makes sure that that ingredient is found in the ingredients list. Then we just need to add that check into our main function so that if this ever happens again, we'll know immediately what the problem is. It'll just tell us, hey, this ingredient wasn't found. Even though you're still going to be getting an error, it's a lot better this way. The earlier in your program that the error occurs, the easier it is to find and the easier it is to fix. Let's debug the program one more time and get to that line with salsa. And we get here, and let's just step over one more time. And we see we don't crash when we get to salsa this time, so that's good. In cases where you have multiple breakpoints and you want to jump between them, or especially when you want a quick way to jump out of a loop without jumping out of the entire function, here's something you can do. You can set another breakpoint at the place that you want to go to, and then hit this resume, or sometimes it's called continue. What this does is just keep running the program until you hit another breakpoint. Since there was only one salsa in the list, this skipped through all the rest of that loop and allowed me to continue debugging from there on. I can now step over and just keep going from there. But since there's not any other breakpoint that I wanted to stop at, let's just resume and let it finish. So we can see that, in fact, it did finish, but it didn't quite do the right thing. It looks like every ingredient got a section to itself, even the ones that were in the same location, like avocado and cilantro are both produce. They should have been grouped together. Also, the printout of the sections looks a little bit weird too. And this is another important lesson that we need to learn. Sometimes things go wrong, but in a way that's not apparent through an exception. So this one will be slightly more difficult to find, but still not too bad. All right, for this last one, let's switch over to VS Code so you can see how to do it here too. In VS Code, you're going to want to go to this run and debug, and then say create a launch.json file. We'll use the Python debugger, and select this first option, which is just a plain old Python file. As you can see, it created this debug configuration with some default options, and it put that in this launch.json file inside your .vs code directory. For some of you, this might work, but as you can see, for me, this is actually going to cause a problem. If I go to run and debug, and I hit the start debugging, you see I actually get an exception right away. Basically, no file or directory recipes.json. It can't find my recipes. But this is the same directory structure as I had before, so what's going on? The problem, which you can see from the command that it ran here, is that it actually ran the command from the root of my project directory, not from where the file was. I do think it's a little weird to have the default be when you say run the current file to not have that file's directory as the current working directory, but whatever, a default's a default. We didn't have to do this with PyCharm because PyCharm makes the current working directory to be the directory of the file by default. But for this case, we're just going to have to set it manually. So we just set the current working directory to this special variable, file dir name, which is the directory containing the file that you just ran. I also typically want this just my code variable to be false. This is another one that I don't really understand why the default is true. If this is true, then VS Code doesn't let you step into or pause on a function that you didn't write. I think diving down into the libraries that you use, not just the ones that you wrote, is a great way to learn how those libraries work. Oh yeah, and those libraries might also have bugs in them. That might be the source of your bug. In any case, let's see if we can get the debugger to work this time. And it does appear like it's working. And we were able to successfully reproduce the error that we had before. At this point, we don't have a whole lot to go off of, but at the very least, we can see bad behavior when it's printed. So we're going to go ahead and start at this function, which looks like it's the only place where it's actually printing something. Let's just set a breakpoint there and see how it goes. The boxes are in different places, but it's all the same stuff. We have our local variables here, which we can dive into in the same way. We can click through and see all of our variables. Watches, these are just expressions that you can watch. It's kind of like an expression that keeps getting evaluated every time you pause, so you can see a certain value. I don't typically use these very much. We have our call stack that we can jump in and out of, and then our breakpoints that are currently set. All of our controls, it's the same stuff. We have continue, step over, step in, step out, restart, and stop. So let's go ahead and step into this print grocery items by location. We define a key function, we define another key function, then we sort our items by basically the where and then the name, and then we group them by the where, then the name, and then we go through and we print those out. So there's not a whole lot going on in this function. This is a great point to let my IDE help me, and notice that this where key is grayed out, meaning this is an unused variable. I defined a function, but I never used it. Another thing that I notice is that this variable is just called where here, which kind of lines up with what I was expecting. I wanted to see where each thing was. Each header was supposed to be a location like produce, not a tuple of produce and an ingredient. Let's just step through to get to the first where. And indeed, we see this tuple containing two items, the where and the actual ingredient, instead of just the where. If we wanted to play around and investigate further, this debug console is the similar thing to what we had in PyCharm. So for instance, if I printed out where here, we would see that tuple. Now we can start to put things together. The looping looks correct, and it looks like I meant to use where, but I'm not using it, which means the groups should have been grouped by where, and where is an unused key. So I'm guessing that this group by, instead of using where then name, should have just used where, which was an unused variable, which would fix both of the two weird things that we found. I can kind of see how this happened, because it's very common to first sort by a key and then immediately group by it, because group by works on adjacent elements. So if my keys were like A, then B, then A, I'd get three groups, A, then B, then A again. It doesn't do the sorting on its own. So if you don't want any duplicate groups, then you need to sort first, hence why it's a common idiom to sort by and then group by. But in this case, I actually want to group by something different than what I want to sort by. I want to sort using this key so that they're sorted first by their location, and then within each location, they'll be sorted alphabetically. But when I group them, I just want to group them by location, not by individual ingredients. Okay, so let's see if that fixed it. We changed the code, but even if you change code after it's already started running, those code updates don't come into effect. So we do need to restart here. Go ahead and try again. And this time, we'll just go ahead and continue. And it looks like everything printed out correctly this time. All the produce are grouped together. So there you have it. That's the basics of debugging in VS Code and PyCharm. But I do have one more piece of advice for you in how to make your debugging more effective. This was a pretty small project. Start to finish, it was just over 100 lines. And because it was so small, we didn't have a lot of friction in just running the program, reproducing a bad result, and then fixing it. But in the worst case, potentially any time you make any change anywhere in the project, anything else anywhere else in the project could now be broken. Of course, it's not usually that severe. It's not like every commit you break something. I mean, hopefully not. And the larger the code base is, the more developers working on it, the longer it's been since you last looked at that line of code, the less practical this just run the debugger and hope to stumble upon the bug approach is. That's why, especially in a professional setting, you want to reduce the problem down to a much smaller problem by writing tests. If you have a rock-solid suite of tests, then you don't need to debug your entire application. You just need to debug the load function, or the load ingredients function, or the choose recipes function. You reduce the scope of debugging everything down to just debug this one function. And even if you can't get it down to debugging literally just a single function, it's still a much smaller surface that you have to cover. Every single one of the bugs that we debugged in this video could have been caught by a simple test. And that would make it even easier to debug because the best time to debug is right after you wrote the code that caused the test to fail. So if you're already going down that route of being a professional software developer, or if you're just getting into larger projects, I definitely recommend spending the time to learn how to do testing. Check out my automated testing video. It's a great place to get started. Anyway, don't forget about the giveaway. If you'd like a chance to win a professional license to PyCharm or one of JetBrains' other professional IDEs, then drop a comment below, #mcoding for a chance to win. I'm James Murphy and my company is mCoding. We also do software consulting, contracting, and training. So if you're in need of those things, please do reach out. Visit mcoding.io. Also, did you know this channel is completely funded by Patreon and other donations by viewers like you, so thank you to everyone who's contributing. If you'd like to support the channel, visit patreon.com/mcoding. Slap the like button an odd number of times, and I'll see ya in the next one.